How to calculate the angle between a line and the horizontal axis. In a programming language, Python, C#, etc., I need to determine how to calculate the angle between a line and the horizontal axis. I think an image describes best what I want. Given P1x, P1y, and P2x, P2y, what is the best way to calculate this angle? The origin is in the top left and only the positive quadrant is used.
First, find the difference between the start point and the end point. Here, this is more of a directed line segment, not a line, since lines extend infinitely and don't start at a particular point. Then calculate the angle, which runs from the positive x-axis at P1 to the positive y-axis at P1. But arctan may not be ideal, because dividing the differences this way will erase the distinction needed to distinguish which quadrant the angle is in, see below. Use the following instead if your language includes an add-to function. Edit, February 22, 2017 in general. However, calling add-to, del3, del-tax, just to get the proper angle for cosine and sine may be inelegant. In those cases, you can often do the following instead. Treat del-tax, del3, as a vector. Normalize that vector to a unit vector. To do so, divide del-tax and del3 by the vector's length, sqrt, del-tax asterisk del-tax plus del3 asterisk del3, unless the length is 0. After that, del-tax will now be the cosine of the angle between the vector and the horizontal axis, in the direction from the positive x to the positive y-axis at P1, dot. And del3 will now be the sine of that angle. If the vector's length is 0, it won't have an angle between it and the horizontal axis, so it won't have a meaningful sine and cosine, dot. Edit, February 28, 2017 even without normalizing, del-tax, del3. The sign of del-tax will tell you whether the cosine described in step 3 is positive or negative. The sign of del3 will tell you whether the sine described in step 4 is positive or negative. The signs of del-tax and del3 will tell you which quadrant the angle is in relation to the positive x-axis at P1. Plus del-tax, plus del3, 0 to 90 degrees. Del-tax, plus del3, 90 to 180 degrees. Del-tax, del3, 180 to 270 degrees, minus 180 to minus 90 degrees, dot. Plus del-tax, del3, 270 to 360 degrees, minus 90 to 0 degrees, dot. An implementation in Python using radians, provided on July 19, 2015 by Eric Leskinski, who edited my answer. All tests pass. See this URL.
Sorry, but I'm pretty sure Peter's answer is wrong. Note that the y-axis goes down the page, common in graphics. As such, the delta E calculation has to be reversed, or you get the wrong answer. Consider. Gives. So if in the example above, P1 is 1, 1, and P2 is 2, 2, because y increases down the page, the code above will give 45.0 degrees for the example shown, which is wrong. Change the order of the delta E calculation and it works properly.
I have found a solution in Python that is working well.
Based on reference Peter O. Here is the Java version.
Trigonometry,